Hi, can you guys hear me? Okay. Back there, you had a question? Okay, awesome. Hi, my name is Anu. I'm a group program manager at Microsoft. Welcome to the session on cloud-powered load testing with TFS. We'll be talking today about the brand new load testing service that we've announced with Visual Studio 2013. This is basically an Azure service that makes it easy for developers to generate load from the cloud to test your web applications. So before I begin, a little bit about myself. Perhaps a bunch of you guys would like to come ahead so you can reach the mic a lot more easier when we get to questions. In terms of logistics, if you have a question to ask, please speak up from where you are or use the mic. If you're not using the mic, I'll just repeat the questions. So my team's built the load service over the past year, which is basically an evolution of the load testing abilities that we offer in Visual Studio already over the past couple of versions. This is intended to help developers find performance issues and fix them and build tests to make sure that you don't really regress in terms of how performant your application really is. So I have been a developer, a tester, a PM. Over the past 10 years, I've been involved with building developer tools for Visual Studio. So my job description sort of read build software, break software, ship software. And I must say I've enjoyed doing all three portions of it. With the load testing service, I actually have a chance to build software that lets people break software. So this has been an interesting assignment. So let's dive right in and see what we are talking about today. We will talk about some of the challenges we have with load testing today. What are typically problems that prevent developers from doing effective load testing? We'll do a brief walkthrough of how to do load testing with Visual Studio, sort of a 101 walkthrough. And then I'll talk about the new cloud-powered load testing service and how you can use that to generate load in the cloud for testing your application. We'll wrap up with a little bit on how the entire service is architected, what's further on our roadmap, and what we intend to do to evolve the service over the next few versions. We're also announcing a broad preview of the load service today, and we are doing an early adopter program. So I'll talk a little bit about how you can enroll into that program to actually get more access and more viewer minutes, or basically more capacity to do load testing on the cloud via that program. Okay, wrong computer. So before we begin, how many people here have done load testing with Visual Studio before? Okay, so about 1/3 of the room. So we'll talk about some basic terms around load testing so that we get our nomenclature consistent over the course of the presentation. When we talk about load testing, we talk about different kinds of load testing, right? Performance testing is basically the fundamental kind of test that you do to validate your responsiveness, reliability, and scalability of the application. So during the course of the talk, we will be doing demos on a particular application that we've built for the demo. It's called a music store. This is basically an MVC ASP.NET website that is an e-commerce application. You can go buy music and order for CDs online from that site. So performance testing in the context of that site really means running a bunch of common scenarios, like a user logs onto your site, browses the site. How fast is the site? Is it responding well to somebody that just logged on and is trying to browse around as to what music you have on the site? Somebody that tried adding music to the cart, somebody that tried checking out music. So basic scenarios, how responsive is your site? How fast does it feel? Load testing is essentially performance testing done in real-world scale. So when I've deployed the website in the real world, how performant is it at that point of time? End-to-end scenarios that somebody performs on your application in the context of a real-world scenario. How performant is your application in those sets of scenarios? So load testing helps you determine performance in a real-world scenario. Stress testing is the other variation of load testing. Can somebody in the audience help distinguish stress from load? What if I give you a T-shirt for the right answer? Shucks, okay, no T-shirt takers either. Stress testing is essentially load testing done under extreme load, not canonical, typical kinds of load, but for the music store example that we are using, this is, let's say Shakira announced a new music album launch. I know as the owner of the music store application that my site's going to get hit with a lot more users than usual. So if I had about 1,000 visitors visiting my site every day, I'm likely going to get about 10,000 users on the day of the launch. So what happens to your application under extreme duress, right? Non-typical loads. In extreme cases, when does the application actually keel over and die? That is really what stress testing is all about, extreme loads. And last, capacity or scale testing is really done with the intention of finding out what's the ability of your application to scale. So in the music store example, let's say as the owner of the site, I decided to go global, and I want to launch the site to be available for music download and purchase in 40 geos instead of one single city. So at that point of time, I know that the user load is going to not just increase from 1,000 to maybe 50,000, but also the fact that the load is going to come from all over the world. So what kind of infrastructure do I need to scale my application to support that kind of demand? Does it actually scale out well? Does it scale up well? To determine answers to those kind of questions, we do capacity or scale testing. Now, the basic construct for doing any of these kinds of testing is really the fundamental building block of perf tests. And we use the basic perf tests in different contexts to determine answers to all these 4 different categories of testing. So what are the top challenges with doing load testing today? So the guys in the session must have come here for solving a particular set of problems. What are the most common sets of problems that you encounter with doing load testing today? No problem. Okay, so load testing is typically done in situations where you want to examine how well your application is responding to changing conditions, right? So the first thing that we really need to do in a real-world load scenario is to provision a test rig that is capable of generating load that's commensurate with the real-world scenario. So in order to do that, you have to simulate users that are using your application, right? So what we do in Visual Studio load testing today is that we have a load test controller and load test agents, a common controller agent model in order to simulate users on your application. So let's say you want to simulate 1,000 users hitting your website. You'll essentially set up a bunch of different agents, each of them simulating a certain number of users on your site. And they're all wired up together to the load test controller, which is basically the central point which will distribute tests to these different agents, collect results back from these agents, and report it back into the results store. So the more number of virtual users that you want to simulate hitting your application, the more number of agents you need to provision. So essentially, this test rig is required to do any kind of real-world load testing. Now, provisioning of this can be pretty painful. You need to go to your IT admin, you need to go figure out how many servers you need, set it up, install the controller agent, do the configuration, etc. It's a one-time install, but it can be pretty complex to do this. And what happens in the case of scaling? So let's say you've actually set up and provisioned this test rig. Now you want to scale up from 100 users to 1,000 users. The only way to scale in this system is to add more servers to simulate more virtual users, right? So you just have to go provision new agents, add them to the mix, and then wire it up with a controller to make sure that you can scale up the amount of load that you can generate. And last but not the least, this whole thing can be an expensive affair. So if you want to do stress testing for special scenarios like a music album launch that might happen maybe a few times a year, it's pretty expensive to maintain this large set of servers, this test rig, with low utilization throughout the year to do that. So there is a certain bursty nature to load testing that doesn't lend itself very well to pre-provisioned rigs that you've already set up and you're maintaining. Now, these are really the kind of top challenges that we heard from customers when we set out to build the service. And this is the primary set of challenges that we seek to solve using the new cloud-powered load testing service. So let's dive right into the demos from the slides. So we'll do a brief walkthrough of how we can do load testing using Visual Studio. So let's go into Visual Studio 2013 preview. These are the client bits that are available starting this week. So like all demos, I start with File New Project. So I go and create a new web performance and load test project. So there's a project type for doing performance and load testing. I choose that project type and I say OK, and it creates a new project for me with a web test automatically added to the project. Now, if I want to test my music store application, I'm going to create a bunch of web performance tests and see how they perform against the app. So if you look at the toolbar here, on the web test, there are a bunch of things that you can do. If I wanted to compose the web test, the easiest way to do that is to just start recording on the particular website. So I say start recording, and it brings up the Visual Studio web test recorder. And I can navigate to my application and perform a simple performance test. So I go to the site and I say, let me actually go browse a bunch of things. So I go to the blues section to see what music is available. I'm not feeling very blue, so I go to disco and I check out some albums there. And it doesn't seem like this is the right place to practice disco moves either, so I'm done. So I just did a bunch of browsing on my web application, and I recorded that in the interim to create a web test. So what's happening here is it's recorded all the requests that were sent out during the course of my performing that particular application, and it's converting that into a web test file. Right? The web test contains the list of web requests that I've made so far. And in here, I can add a bunch of validation rules to make sure that when I went to the home page, I really saw the logo. Or when I went to this particular blues section, I saw this specific album. So there are a bunch of validation rules that you could add in here. So let's go rename the web test to something that reflects its actual intent. I say browse site.webtest. And I'm going to run this web test to see what it really does. So I hit the run button on the website, on the web test, and what it's doing is it took the set of 4 requests that we recorded while creating the web test, and it's executing it on the fly. So in the Visual Studio IDE itself, you can actually see what happens when each of these requests get submitted to your website. So it shows you sort of dynamic view of what happens when the web test execution is going on. In here, it also shows some interesting statistics about how long did it take for the request to go through. So the first time that we hit the website, it seems to be taking 13 seconds to load, which is pretty huge. So that sounds like an area that we should likely go fix, because that can make your website look pretty unresponsive. So you want to drill deeper into why that took 13 seconds. So there are a bunch of other details that you can see in the web test execution details that tell you what was the precise request that got sent to the server, and what were the contents of the details in the response that you received. And from here on, you can actually drill down further to see where in your application you should make performance fixes in order to make the site a lot more responsive. So we will do that in a while, but let me actually go add another web test to make sure that we are covering a bunch of interesting real-world scenarios. So browsing is great, but I'm pretty sure that users that come to the site will also want to buy some music. So I'm going to go back to the web test recorder, add another scenario which is going to be buying some music. So I go to blues, I pick a particular album, I say add this to cart, It's added it to the cart. I go back to metal, and I say, okay, ace of spades. Let me add this one to cart as well. And I've added 2 CDs to the cart, and it's looking good. It's showing me that all of this is available in the cart. So I stop at that point of time and add yet another web perf test that does a similar but a different scenario on the site. So running it is going to give you similar insights as what our browse site web test did. What the web test recorder also does, in addition to just create a sequence of request URLs, is it detects dynamic parameters and automatically creates parameters out of them. So if you had on-the-fly generated content in your request URL, like session ID, which is unique to the user that's currently running the test, the tool automatically detects that and parameterizes it so that the next time around that you run the test as a different user, you don't really have to do anything different. So we go here and we rename this to add to cart. And when we look at the 13-second delay in the first page getting rendered, it's likely that I'm going to go make a fix on that. So when the developer makes a fix and deploys the site to a different environment, the URL against which I want to run this web test is going to change. Right? So it won't be the production URL that I run this against. At that point of time, if you look at the web test, it actually has all the requests containing exactly the URL that it was pointed to. Now, if I want to change the site against which this web test gets run, I have to go back and edit each of the request URLs, which is pretty tedious. So in here, we've built a functionality that lets you do that pretty easily, where you can say, parameterize the web server that I'm pointing to. When I say that, it automatically detects what is the web server that is currently being targeted in this website and creates a parameter automatically out of it. So I just hit OK, and now you see that the request URLs in here are actually pointing to the parameter web server 1, which currently has the value demo music store. So if I just change the parameter value the next time around when I've deployed the fix, the entire web test gets run against the new server. So I save this, I go to add to cart, and I do a similar exercise. That was easy. So now that we have performance tests written out and run against the site, it's the next interesting step to really perform is to see how these performance tests behave under real-world load. Now, real-world load means 2 things. Not just the fact that in production there are many users using your site concurrently, so there may be 100 users that are currently hitting your site concurrently, but they will also be doing complex operations. It's not just a user that does a browse or a user that does exclusively an add to cart. So you need to construct complex sequences of those actions when you're doing load test. So let's see how to do that using these 2 web performance tests that we've just created. So I go to the project and I say add a new load test, and the load test wizard pops up. This walks you through the different stages of constructing a load test. So I say, okay, let's begin, and I'm going to say a simple scenario of browse and add to cart. That's what I want to test in this particular load test. You can construct different scenarios and run them as part of the load test, checking out or maybe returning a particular CD, creation of user account. So as you construct more and more complex operations, the load test becomes more and more realistic, and you have a better chance of figuring out where the weak link in the application is. So I define a simple scenario, and I also get to specify a think time profile for the scenario. In real world, users don't always just do click, click, click on your website, right? They're going to take their time, look at the CDs, figure out whether they like it or not. So there are pauses in between performing each of those operations. Now, it's interesting for testers to simulate those pauses because those could really trigger changes in behavior of the application. So you have an option while constructing your load test to figure out whether you want to apply a particular think time profile or just apply a sort of normal distribution of think times throughout the entire scenario. So I choose the default, and I say, OK, you know what? I think I'm going to simulate about 100 users hitting my site at a constant rate. So I'm going to say 100 users is what I want to simulate in this particular site, in this particular test. And then I can pick the test mix, how I want the test mix to be modeled. We'll talk a little bit more about that when we construct some more complex load tests. Now let me add the tests that I've created to the load test. So we created 2 web performance tests earlier, so I'm going to add both of them to the load test because my scenario is that somebody browses and then adds that to the cart. So I have both of these added to the load test with an equal distribution, which basically means the 100 users that I'm simulating, 50 of them are going to do browse site, 50 of them are going to do add to cart, or basically they're going to spend equal amounts of time doing both. Now that's not very realistic. From experience, I know that a lot more users just log on to the site and browse for new arrivals rather than buy a particular site, a particular album those number of times on the site. So I'm going to increase the distribution of one particular test there to be a lot more than the other one. So I'm using approximately an 80-20 sort of distribution of browse versus add to cart. So you can determine which of the tests you want to run more often and in what proportion. So now that we've already defined what tests to run, how many users are we going to simulate on the application, there are 2 other options you can pick to simulate something in a more real-world environment. One of it is the network mix. So the network mix essentially dictates what are the kinds of networks to simulate that your users are coming in from. So there are a bunch of different network types that you can add and create a similar distribution as the previous set of tests that I showed. This is going to actually kick in the network emulator that we have in load test, which is going to simulate either smaller, lower bandwidth networks or higher bandwidth networks based on what you think the distribution of your usage looks like. So I'm going to keep this load test simple and have just the LAN. And the second option really is to specify the browser type. So you can essentially tell the load test to use a mix of browsers to send the web requests in. So the request is going to be appropriately modified based on the client, the browser that it's coming from. So I could add different browser types and again do a similar distribution exercise. I think that most of my users will come from IE because IE is a really cool browser. The fact that I have Chrome ahead of IE is not very inspiring for that argument. So I'm probably going to leave it at 50 and 50. So let's remove or let's actually keep it simple at just one browser type, so we can use multiple browser types in the next load test that we create. And before we actually finish up creation of the load test, you have an option to actually go and specify what counter sets you want to collect apart from what gets collected by default. By default, we collect a bunch of interesting metrics like what was the processor looking like, what was the memory consumption looking like, what were the pages per second, the client-side perf metrics, and a whole lot of related obvious default metrics. But you could potentially add a different computer here and collect counters on that site to see how your server side is performing when the load test is actually executing. So finally, to wrap up how the load test should actually run, you can go specify a bunch of parameters in the run settings dialog. The most important one of it is the load test duration. Typically, a load test runs of the order of hours. I'm just going to make this 1-minute load test here so we can see the end-to-end demo happen in a much faster pace. And you can set a sampling rate of how often you want to actually collect the counters that we just saw in the previous tab. So now that we've seen all the different components of what goes into a load test, we hit close and it generates a load test based on all the configuration that we just made. So now I have a load test with this distribution of web tests with a constant load pattern of 100 users. Now all I need to do is actually go run this. Now I can run this in 2 modes. I can run this either locally, where my desktop, in this case my laptop, is going to simulate the 100 users that I've asked the load test to simulate. Or I could point it to the test controller and ask the test controller to distribute it among different agents so that each agent can simulate part of the users that I want my load test to actually simulate. So here in load test manage test controller, here is the place where you can select what controller you want to connect to and what sets of agents are really wired to that controller and distribute how your tests are going to be run. For the sake of this demo, I'm going to run it right on my laptop. So my laptop is going to function as the load agent. And when I say start the load test, it's going to run the load test by simulating all the virtual users right on my local machine. When I hit run test, you see there is a detailed load test report page that comes up, which shows graphs of key performance indicators, the ones that were chosen by default in the counter sets tab. And those get plotted dynamically as the test gets executed. So you can see interesting metrics in here that we collect, which is pages per second, what was the average page time that the entire load test saw, and what were the kind of threshold violations that were seen when I simulated 100 users on the application under test. If you want to monitor specific metrics that are not in the graph, it's easy to just go add it from here. So if I want to monitor processor time, I just pick the right counter and drag and drop it onto the graph, and it plots the appropriate counter. So I go back to graphs, and now my load test run is complete, the 1-minute load run that we just started. So we have the summary of the load test run coming up. So the summary shows some key statistics. In our case, the top 5 slowest pages may not be very relevant given that we had only 2 web performance tests. In a real world case, you want to see which of your pages are really slowing you down, what's taking the longest to load in your website. And interesting results around what was the amount of requests per second that your server could actually handle. So what were the requests that were sent, how many requests actually failed, how many pages per second were served. The load test report summary gives you a good overall summary or an overall aggregation of the 100 users that were simulated and the number of tests that were run as part of the load test. Now, you want to drill deeper into why the requests per second were low or why the pages served per second seems like a low number. You have a variety of ways to actually do that. So you can see the graphs themselves will indicate spikes or troughs where you want to go figure out more details on why the app is behaving that way. So you have different levels of detail right in the load test report to dig deeper into what could potentially be causing those performance aberrations. So the virtual user view actually has a zoom in terms of time period, and it shows you what every single virtual user has done. So the 100 users that we simulated, the chart shows what happened in the case of each virtual user, how many seconds did each test take to run, which user did what test, etc. Now, given that all of this rich data helps developers analyze what the problem is with their application and what are the sets of performance issues they need to fix, we presume that once the developer actually figures out what fix to make, he checks in the code and then he deploys this to a particular test environment. So I'm not going to go into opening the solution and showing you the code fix here, but let's assume that the code fix is done and checked in and deployed to a different website, which is Music Store 2. So if you look at the URL, it's changed from Demo Music Store to Demo Music Store 2. So I want to run my load test now against this new and improved Music Store 2 application to see whether the performance fixes that the developer did really helped make the application faster or not. In order to do that, it's pretty simple to go make that change in the load test because if you remember earlier on, we parameterized the web server on both our web performance tests. So I just have to go to run settings and say add a context parameter. So I click on add context parameter and it creates this parameter for me in the properties table. So I'm just going to say web server 1 is my parameter, and the new URL where I've deployed the fix in. And once I've actually made that change, I can simply go run the same load test against the newer URL, which contains the performance fix, to determine whether the request per second or the metric that I was trying to improve has actually improved or not. Now, when we do these load runs, typically what happens is there are a variety of metrics that get collected. And it's not always simple to compare run over run, whether those metrics improved or got any worse or stayed the same. Now, to do that in a lot more simple manner, what we've done is we've introduced the run comparison button here, which basically does, let me zoom in a little bit to get you see. So the run comparison functionality is intended to help developers get a little bit more of a graphic visualization of what happened across two load runs and whether critical parameters actually improved between two load runs. So while the other load run is running, I'm going to say, create a load test report for me. And in Excel, I get a wizard that says, what's the report you want to create? So I'm going to say, create a run comparison report, which lets me see how the load test results between Music Store 1 and Music Store 2 actually differed. So I create a run compare, and I pick these two, and I say finish. So what Excel does is it picks up all the data from the load test results of each of the runs that I have selected and generates a comparison for me to look through at the very top level. So if you look at the baseline, which was my previous run, and the comparison run, it's actually gotten worse. So we've introduced a perf regression in the site instead of fixing the perf issue that we detected. So the average test time has increased, the average page response time in terms of how long it took for pages to load across these two runs also seems to have increased. So the report actually helps you look at sort of a visual comparison of how these metrics have changed across these two runs. Now, given that we think this is a perf regression, we're actually going to go through the whole cycle once more, making the appropriate perf fix and running load test. But the beauty of the solution is that you've created a load test once, and you get to use that build over build and do comparisons build over build with very little effort. So this was pretty much our end-to-end experience of how you use Visual Studio to run load tests with creating on-premise controller and agent rigs. So you want to scale up further, you just add more agents into your controller agent mix. So just as a quick recap, we saw how configuring the test environment is really done via the Manage Test Controllers tab, where you have the controller and agents set up. And then we authored load test. We went from doing performance tests using the web performance tests, add to cart, browse test, to doing load tests, where we composed a load test out of these web perf tests. Then we moved to stress testing, where we actually said add more agents and simulate 1,000 users instead of 100 users. And we analyzed the results, found a performance issue, but apparently didn't do a good job of fixing it because it introduced a regression. But essentially, this is sort of the end-to-end workflow that we have with Visual Studio for load testing. So before we get into the service, any questions so far? Yes, sir. I'm sorry, I cannot hear you. You'll have to be louder, or you'll have to come to the mic.
Can you create a subset of the data you export? So if you run this test for 3 hours with 100 users, you'll have a big data to export.
Correct.
Could you create a subset to export and compare?
So in the Excel report, you can certainly create a subset comparison. However, we download all the data at one shot. There is no option that I can say where download just the last hour of the load test result data yet. But that's a good question. That's one that we've heard our customers ask a few times before. Just one sec. Sir, you had a question.
What if the user get a user ID on the page and have to reuse that in the URIs?
Right, that's a good question. So what if there is, the question basically is, what if there's a user ID that needs to, or a session ID that needs to actually be propagated across requests, where I need to take it from one request and feed it to another? Yes, you could very well do that. So you could do that from the web test either through a straightforward scenario where you just pass parameters from one request to another, or if you want to do further customization, it's easy to go generate code out of this web test. I did not show that in the demo, but essentially there is a way in which you can generate code from the existing set of web test recording that you did. So I hit generate code, and it creates a C# or a VB test where, oh, sorry, how did I get there? Let's see. Okay, there it is. So what I was showing here was, once you have the web test, you can actually go and say, I want to generate code on this web test. So there's a generate code button available here where you can do further customization of the web test. So I say generate code, and because I did this earlier while I was not projecting, it's asking me whether it needs to override. But generating it is going to create a C# or a VB.NET web-coded test where you can do more sorts of customization or save any kind of variables you want to save and reuse them in the course of running the test. So any kind of advanced customization you require to do could very well be done using the coded web test. Yes?
Can I make a load test to a WCF service endpoint?
I'm sorry, can you please repeat the question?
Can I make a load test to a WCF endpoint?
Yes. So that's a good question. The question is, can I have a load test tester, WCF endpoint, or any other non-web application endpoint? The way that we ask users to do load testing on, if you don't want to use web tests directly on your website, is to create unit tests that can target your particular WCF endpoint. So load tests can be composed of both web tests as well as unit tests. So as long as you target your WCF endpoint within your unit test and you're collecting interesting metrics, you can just go run them in the load test container. Okay, great. So good questions. So let's dive right into how we're now making this whole provisioning of test rigs and switching from load to stress to scale a lot simpler using the new cloud-powered load testing solution. So we will go right into the demo. And let's see if I can get this right. Okay, so this one's going to be a bit challenging. Give me a... Okay, a lot better. So what we're going to do with the cloud-powered load testing is we're going to use the same set of tests that we authored already, the web performance test and the load test, and just point it to run from the cloud instead of running it from my local laptop or from the controller agent rig on-prem. So let's open the load test. And this is the one that we authored earlier. And the solution contains something called a test settings object. So I open the local test settings object, and in here, there's an option that says, where do you want to run these tests? I had originally picked by default tests, run the test using local computer. Now, all I need to do to run this on the service is to go pick the second radio button and say, run this using the service. And then I apply and close, and that's it. So that's pretty much what you need to do to go run your load test on the service. Now, I'm going to go say, start this load test, and I already have a VS Online account that I'm connected to on this particular machine, which is why it did not prompt me for credentials. But if I weren't connected, it's as simple as your regular Team Explorer experience. You type in your VS online account, live ID, password, and you're connected to the service. So now when the load test is now being run on the cloud, you see a slightly different experience of what's happening to the load test. So we show a page where you can see what's currently the state of the load test that we're. Apparently my Zoom skills are not all that great. So you can see what's the state of the load test that it currently is in. What it did was it said it's acquiring resources in the cloud, so it spun up agents on the fly based on the amount of users that you wanted to simulate. And then it uploaded the load test to the service, and now it's executing the load test on the service in the cloud. So while the load test gets executed, you can see a similar experience as what we had with the graphs earlier, but this is more of a web-based experience, very similar to Visual Studio Online for those of you that have tried out the TFS service. We show what's currently going on with the load test that's running in the cloud in terms of key metrics. So you can see both the performance and the throughput that's being generated by the load test, and you can see and you can kind of track how the test is performing. So I see different kinds of counters in here that I can plot. I can see interesting metrics. I see that the request per second is pretty much about 51.4, which seems like a pretty healthy metric at the moment. So I can go and dig into each of the different metrics on this load test by looking at the detailed report of the load test. Now, since this is running on the cloud, the detailed test result report is also available on the service. So any kind of detailed analysis that I want to do on the client, I will need to download the report. So what I'm going to do is, once the load test is done, from in progress it moves to completed. As you can see, it's collecting the results. It's collecting the results and downloading them back into the client. So once the report has actually been generated, I'm going to go say download report. So I download the report and it brings it onto my client. And when I view the report, we are back to exactly the same set of rich metrics that you can see when you execute the load test on premise. So from here on, the experience is exactly the same as what it would have been if you had configured a controller and set up agents and run this load test yourself on premise. So now that we can run the load test with 100 virtual users on the cloud, it's interesting, but I could have run the 100 virtual user simulation right on my laptop, so it's not really a big deal. Now what happens when, for my music store application, I need to prep for the Shakira music launch? So in that case, 100 users just doesn't cut it, right? I'm going to increase tenfold and say I want 1,000 virtual users this time around. And I want to simulate that using 4 agents. So I go to the load test. How I do that is fairly simple. I go to the load test and I go to run settings. And there is a property called agent count, which lets me specify how many agents I really want to spin up in the cloud. So by default, it's set to 0, which basically means it's going to take 1 agent and simulate all the virtual users that you've asked it to do. I'm going to change that to 4 agents because I want to now simulate 1,000 users. So I go to the load pattern in the load test, which is right here, and there from 100 users, I'm going to make that 1,000. So now I just increase the traffic to my site by 10x, and I'm going to simulate that using agents that the service will spin up for me. So instead of having to actually provision multiple agents and connect to the controller, I simply had to change property in terms of number of agents to spin up and indicate how many users to simulate. So I say run, and now you see the load test gets queued, And the acquiring resources status message essentially indicates that it's going and spinning up these agents in the cloud while acquiring resources so that it can simulate these 4 different agents to get 1,000 virtual users worth of load to hit the application. Now, while it's acquiring resources and running the test, so you see it went into in progress state within a matter of few seconds. So we have a test agent pool that we use for load tests to consume in the cloud so that it's pretty easy for generating anything of the order of 4 agents or 1,000 virtual users. So I'm sorry about that. I just realized that my phone still works. I flew from India to here yesterday, and I thought my phone was dead, but it decided to work in the middle of a demo. I take that as a good signal and hope the rest of the demo works just fine. So the performance test, as you can see, has now gotten 4 agents to initialize. It simulated the 1,000 virtual user load that we asked it to simulate. So you can look at the throughput. Now the requests per second should actually have gone through the roof. So if you look at the values here, it's now about 290, about 300, which is about 10 times of what we saw on the previous load test where we were simulating just 100 virtual users. So this was interesting. We could actually go scale the load generation rig and prep our website, the music store website, for a burst, for a stress kind of situation, which was a one-time of what happens if 10x users suddenly hit the site. Will my application be able to sustain or not? Now, this is useful in the context of a stress test. What is the next stage of evolution of doing this? What if I wanted to actually test whether the music store app can sustain itself if I opened it up to the 40 geo scenario instead of just one single location? At that time, it won't be 1,000 users. It'll likely be 10,000 users. And 10,000 concurrent users hitting a site can be a lot, right? So what happens if I want to generate 10,000 virtual users to hit my particular application? That basically means I need to probably go from 4 agents to somewhere around 20 agents if I do the computation. So I go back to the load test, and I say that instead of the constant load pattern that I've said of 1,000 users, when I really open it up to a scale of 10,000 concurrent users, I will have to do it in a step fashion. It's not like 10,000 people are suddenly going to do blitzkrieg on your site. It's probably going to increase in steps and hit a max limit and then likely wind down. So I'm going to change the load pattern of my site to move from constant to a step-based load pattern. I'm going to say I'll start from an initial user count of 100 and simulate 10,000 virtual users. And I'm going to step it up each time by, let's just increase it to 1,000. So I'm going to hit the site as I'll start with 1,000 users, then I'll increase it to 2,000, 3,000, all the way up to 10,000. So now I'm getting into like serious stress and load scenarios where I simulate all the way up to 10,000 users. That means I'm going to have to change my agent count. I cannot have 4 cores simulate that kind of load. So I'm going to go change this to 20 and say, you know what, spin up this monster rig, which has 20 agents simulating my 10,000 virtual users. So I do just that, and I say, run the load test. So graduating from stress to scale is a very similar exercise as graduating from load to stress with a service, because you essentially did not need to worry about how the extra 16 cores and agents got spun up. Now, the service has a pool of test agents, but we don't have an unlimited pool of test agents, right? So you want to spin up something as huge as 10,000 virtual users hitting your site with 20 cores. What we do at that point is we don't use the warm agents. We have to go beyond the pool and instantiate new as your roles just for creation of this particular rig. And that takes of the order of 2-3 minutes to complete. So you're going to see the acquiring resources status on the load test for a much longer time if the scale of your load test is pretty high, somewhere around 20 user agents or so. So while the load test actually is running, let's go back and see how you can keep track of what are the load tests that I ran with my Visual Studio Online account. So earlier with the on-premise solution, it was as simple as you just go look at the load test result, the thing that we just saw with the 4 graphs and tables, and you could see a list of runs that happened. Now, with the Visual Studio Online account, it's important that you know how many virtual user minutes you've consumed, who are the people on your team that have run these load tests, what have those load tests gone like, has it been useful or not. So what we've done is we've introduced a new Explorer window called Load Test Manager for load tests. This is very similar to the VS Online web-based experience that you see. So we've built this ground up to be a lot more web-like. So in here you can see there are different load tests that are listed on the left-hand side. So you can see who did how many load tests, what are the different kinds of load tests that have been run on this account so far. There are filters here where you can go and see load tests that have been done for any given time period. I say any, and I see you've done a truckload of load tests in here. You can see who has requested each of those load tests. What's the user count that has been simulated? So if you look at the user count, you can see that it's elastic. It stretches all the way from 10 virtual users to 10,000 virtual users. You can see when it was started, when it ended, and other interesting metrics that you want to drill down into. You go from here to the load test result. So you can see this one is queued. This is our Monster 20 agent run, which is currently waiting on resources for agents. So let's pick a completed load run. And it takes you back to the load test result view. And from here on, next level drill down is really the report that shows you the different graphs and tables for this particular load test. So it's pretty much an end-to-end seamless experience right from the point of who has done what load tests, how many virtual user minutes have been consumed on your account, so you can keep tab of how your load test consumption is going like, and get down all the way into the detailed, rich reporting and analysis that Visual Studio already gives. So let's go back to our load test manager and let the queued run complete. So we'll go back to our slides and give this a few minutes for the load run to complete. Any questions so far? Yes, sir.
Hi, Anu.
Hi.
Any way to control where actually your instances are being provisioned from? So let's say that your application is deployed on like 5 or 3 different data centers, and then you have traffic manager routing the traffic depending on where your request comes from. So this stress test that you're performing, are all the requests coming from the same data center where your TFS subscription is, or can you actually control saying, hey, I want to push a stress test, but I want 2 cores from the United States, 2 cores from
Right.
Europe, etc.
Right. Yeah, that's a great question. Currently, for the preview version of the service, we do not provide an option for you to tell us which data center to generate the load from. However, that's a very interesting ask that we hear all the time that's featuring pretty high on our product backlog to allow for geo-selection of where the load should actually come from. Right now, it's just one single data center that we control. So I'm going to also get back to that question when we talk about product backlog, because we have a number of requests on the roadmap for the load test service. I'd love to hear from you around how important you think some of those requests are, or whether we should reprioritize those. Yes?
If we need to get the performance counter information, we need to run a test agent on the machine running our application. Is there support for deploying application with test agents on the cloud, or this is only for simulating user load?
Yeah, that's a great question. So the question essentially is, if I wanted to collect metrics from the application under test, can I go deploy my app under test also in Azure, and will counter collection actually work on the deployed application in Azure? The answer to that is yes. We've had several teams that are testing Azure services. I will talk about that in a little bit more detail. See, you can potentially collect counters from the deployed application in Azure and then correlate it with the collected results. But in our existing preview of the service, we've not given an integrated experience for you to just point to the app and say, you know what, Azure Diagnostics from this particular set of roles, just collect ABCD and superimpose it on top of the perf counters you've collected on the agents. That integration ask is actually the #1 thing that we're working on right now as the next evolution of the service. Great questions. Yes.
I also have a question. So if the application runs on-premise, is it also possible to run the load agents against the applications running on-premise to connect via virtual network back to my data center, or is this somehow possible?
Yes. So the question is, how do I test applications hosted on-premise? The service needs that your application be a publicly available endpoint. So what you can do is, even though you've hosted it on your own on-prem data center, as long as you make sure the endpoint is publicly available, you can use the service to load test it. Another alternate that we've done for a couple of our early adopter customers is we've given them IP ranges and said that open up the endpoint of your application only for this particular IP range. So that sort of limits your surface area. So you don't have to open an entire VPN for this particular scenario. Okay. So great. If we have no more questions, let's just do a quick recap of what we did. So with the load service, the primary thing we're trying to do is to eliminate the pain of configuring the test environment up front so that we can run tests, analyze results, and really focus on the meat of why people do performance testing, which is to fix performance and scale problems, right? So we hope that by solving the provisioning pain of load test rigs, we free up developers to really focus on the essence of doing performance testing, which is to make your app a lot more faster. So let's now transition into the last segment of the talk, where I want to give you a little bit of an overview of how we've architected the service, because quite a few of you said you've used the load testing capabilities of Visual Studio earlier, and you're familiar with the controller agent architecture, the thing that I showed in the beginning of the talk. Now, what's the simplest way to build a service which will do the same thing on the cloud, which will simulate load generation on the cloud? One option could just be to take the controllers and agents and host them in the cloud, right? Now, that, however, has two primary problems. The existing architecture has two primary problems. One is that the controller is really the bottleneck in that entire system. The controller has to collect the load test requirements, break up the test, distribute it to different agents, and then collect the results back and then report it into a particular format. Now, the problem with that is if I have 100 users consuming the load test service, using the controller agent model becomes a bottleneck very, very quickly. The second problem with the controller agent model is that the controller is a stateful controller, which means it's a single point of failure. So if the controller goes down, it's pretty much boom, the entire load test run results are lost. So it makes the system very frail. So when we started building the service, the load testing service, we designed it from scratch to make sure that reliability and scalability are addressed as first-class concerns. So what we really do today is, from Visual Studio, we just call the REST API for the load test web service and tell the service, here's the load test I want to run, these many users, these many agents, here's the test. And from the load test web service, the worker roles actually pick up the tests to run and make sure that the appropriate number of agents are assigned to this particular load test, and each of these agents run the load tests in parallel. So once the tests are run in parallel, they just go right into the results database themselves. So we don't really have a single point of failure or an entire role just bottlenecking the whole system. So the entire service has been architected from scratch to make sure that it can scale and it's super reliable in different scenarios and different sizes of test rigs. So we use the Azure tables and Azure blobs to really store the load test results, and this is what you see as the download report sort of experience. We bring it down from the cloud. Now, given that this was pretty much building the service from scratch, what we did was to ensure that we are doing customer-driven development. In this case, we went and engaged with early adopters. I give talks on software development all over the world on many topics, but invariably the one common question that I hear from everybody during these talks is, how does Microsoft do it? What do you guys do to solve this problem? And on this service, I'm happy to report that we've been one of the biggest dog fooders of the service. We call Microsoft products using their own products to do engineering work as dog fooding internally. So the Team Foundation service, which is basically the ALM service that we offer online, hosted version control and work item tracking, this uses the Elastic Load service to do their performance, load, and stress testing. So the sprint deployments that we do of the Visual Studio TFS service have all gone through the load testing service in terms of doing perf and load testing. This is a huge service which scales to a huge number of customers, and this has grown pretty exponentially over the past few months. So having the TF service consume the load service has been an interesting exercise and has given us a lot of feedback in terms of what are the areas we need to work on in the load service, which are the sets of issues we should fix. So I heard two issues come up here, which was server-side data collection, geo-distribution of load. Both of those came up as pretty highly important asks from this exercise as well. Skype is another instance of a service using the load test service to do their load and perf testing. We've also had about 10 external customers use this in production and sign off on the service before we've announced the public preview on this. An interesting case that I want to reference there is the Florida state elections. I'm not sure if you guys have the context of this one, but the Florida state elections exercise was pretty huge scale. So the CIO of that whole setup actually used an Azure-based web service to do voter registration. And we used the load service to make sure that the Azure service that was built would scale to an electorate of that size in terms of figuring out, will it perform reliably? Can it take the hit of those many users during election, et cetera? So this has actually been a super interesting exercise for us in terms of getting feedback a lot earlier than putting it out publicly. So based on this, on our backlog, we have collecting perf counters from server side, the thing that our gentleman here was just asking about, richer analysis and reporting for in-progress runs. So the graph that I showed you, which was currently showing data for runs in progress, the performance and throughput bits, we want to improve that and show a lot more metrics and not necessarily just the perf and throughput group. Scheduling of load tests is another ask that we've heard. So it's all nice to actually go and say, I want to kick off a load test now, but what if I want to kick off a load test every Wednesday night? The whole intent of making the load service easy to use and consume is to make sure that developers can run these tests a lot more earlier and frequently in the cycle. And scheduling of those load tests automatically is a way to actually meet that goal. Geo-distributed load generation we spoke about earlier. It's really the ability to go say, here, go generate load from this particular data center because my app is hosted here, or those kinds of things. So these are kind of the big bucket of asks that we've heard from consumers so far on the load service. And now that we've opened it up for public preview, I'm guessing we'll hear a lot more different sets of asks on the service. So in terms of next steps, what can you do? We've announced the service for broad usage, so you can try it out with the Visual Studio 2013 preview. The client bits are available as a free download, and Visual Studio accounts are creatable by anybody. So you can essentially have just the client and a service account, the VS Online service account, and you can kick off your load tests today using these. The service is free to try and use during the preview. We have some usage limits set on usage, because we'll probably be bankrupt if we open it up entirely. So we have 15,000 virtual user minutes per month for any trial account. And we are running an early adopter program for people that want to do load testing beyond of that particular scale. So if you're interested in increasing the amount of load testing that you can do per month, the amount of cloud capacity you get to run your load test runs, you can join the early adopter program on the link that I've put up there. It just involves filling up a form and figuring out how much of capacity you really need for your load tests to run on the cloud. So this will entitle you to more usage, and you'll also have the product team work with you in close tandem. So to conclude, the intent of building the service was really to solve these 3 challenges that we talked about in the beginning of the presentation. So here, with the service, we've solved these 3 challenges by making sure that you can do automatic provisioning. You saw how you could do automatic provisioning by just saying connect to the service in the test setting. It was one radio button. It's easy to scale based on number of agents. There's no creation of agents or configuration. It's just a number. It's a property that you change. And you're paying for what you use. The payment model on the service is in terms of virtual user minutes. So if you want to simulate 10,000 users for 2 hours, we will charge you as per that, instead of how many times are you going to do the load test run, or instead of like a slab of usage that you have to pay for in case of on-prem usage. So let's just actually quickly pop back into our 20 agent run and see what happened to that. Okay, so apparently it's still in progress. Oh, great, so it's now collecting results. So you can see how this lilac line here represents user load that's kind of gone through the roof in terms of, because we applied a step load of 1,000 users each. So it's gone all the way from simulating 1,000 users on the music store application up to 10,000. And you can see how the throughput has really struggled with that kind of load. So the requests per second have also gone up, but not really something that would be commensurate to that kind of load. But you don't really see any exceptions or crashes in your website, which is sort of the first level of good news. Any kind of drill down that you want, you can download the report and see further. But essentially for this run, we've simulated 20 different agents and hit the website with about 10,000 users. Okay, so with that, I wrap up my talk and open up for questions if you have any. That's my Twitter handle. Feel free to ask me any questions on Twitter, and my email ID. Also, we have the VS ALM product booth here in Hall 8. Please feel free to come by and try the load service for yourself. As long as you have a public endpoint, you can pretty much use the booth to go hit your site and see how it performs against any given load. Any questions? Yes, sir?
Are there any future plans for porting the lab management feature set to the cloud also?
Yeah, that's a good question. When will we have a lab in the cloud is the question, effectively. Unfortunately, I cannot answer that question as to will we have a time frame for releasing this, but this is definitely one of the highest priority items that we are looking into as a product line. This is a common ask that comes up, especially with the Azure IaaS announcements that we've made recently. We're looking into what we can do to improve the experience of the existing lab management product there, as well as provide a sort of service that can make use of the Azure subscription. Any other questions? Okay, thank you so much. You guys have been a wonderful audience. Thanks. One last thing, please fill up the eval forms that are handed out. I think they're online eval.